The Big Bang theory is the leading scientific explanation for how the universe began. It proposes that the universe started from an extremely hot, dense singularity about 13.8 billion years ago and has been expanding ever since. This theory is supported by several key observations and pieces of evidence, including 1. Cosmic microwave background radiation, CMB. Discovered in 1965 by Erno Penzias and Robert Wilson, the CMB is faint radiation left over from the early universe, acting as a snapshot of the cosmos just 380,000 years after the Big Bang. 2. Hubble's law and the expanding universe. In the 1920s, Edwin Hubble observed that galaxies are moving away from us, with their speed proportional to their distance. This suggests the universe is expanding, which supports the idea of an initial explosion-like expansion. 3. Abundance of light elements. The Big Bang nucleosynthesis model predicts the proportions of hydrogen, helium, and trace amounts of lithium in the universe. These observations match the theoretical predictions. 4. Large-scale structure of the universe. The distribution of galaxies and cosmic structures aligns with predictions from simulations of an expanding universe that originated from a dense initial state. What happened during and after the Big Bang? Planck era, 0.10 superscript 3 seconds. The universe was infinitely hot and dense, and the laws of physics as we know them do not apply. Inflation, 10 superscript 3 seconds. A rapid expansion occurred, making the universe uniform and smooth. Formation of fundamental forces. As the universe cooled, fundamental forces, gravity, electromagnetism, strong and weak nuclear forces, separated. Nucleosynthesis, 3 minutes after. Protons and neutrons formed nuclei of hydrogen and helium. Formation of atoms, 380,000 years after. Electrons combined with nuclei, forming neutral atoms, allowing light to travel freely, CMB radiation. Galaxy and star formation, hundreds of millions of years later. Matter clumped together under gravity, forming galaxies, stars, and planets. Common misconceptions. The Big Bang wasn't an explosion. It was an expansion of space itself, not a burst into empty space. It doesn't explain the origin of the universe itself. It describes how the universe evolved from an initial state but not what caused it. Expansion is happening everywhere. Galaxies aren't moving through space. Space itself is expanding. Unanswered questions. Scientists are still investigating aspects such as: what triggered the Big Bang? What is dark matter and dark energy? Will the universe continue expanding forever, or will it collapse? Want to dive deeper into any specific part? You said. Story of Big Bang. ChatGPT said. Sure. Here is a simplified story of the Big Bang, told like a cosmic adventure. A long time ago, in a tiny, hot, and dense point. Once upon a time, about 13.8 billion years ago, there was no universe as we know it. No stars, no planets, no galaxies. Instead, everything that would ever exist was packed into a single, unimaginably tiny and dense point. This point, called a singularity, contained all space, time, and energy. Then, in an instant, boom, not an explosion in space, but the sudden and rapid expansion of space itself. This moment marked the beginning of everything, the Big Bang. The first moments, chaos and creation. In the blink of an eye, the universe expanded faster than the speed of light, in a phase known as cosmic inflation. Space stretched out, smoothing the cosmos and setting the stage for everything to come. At first, The universe was scorching hot, a chaotic sea of pure energy. But as it expanded, it began to cool down, and energy started transforming into the fundamental building blocks of matter, tiny particles like quarks and electrons. In just the first seconds, quarks came together to form protons and neutrons, the core ingredients of atoms. The first atoms, let there be light. After about 3 minutes, things cooled down enough for protons and neutrons to bond, forming the first atoms, mostly hydrogen and helium. The universe was still a glowing, hot soup of charged particles, preventing light from traveling freely. Fast forward 380,000 years, and a magical moment happened. Atoms finally captured wandering electrons, becoming neutral. Suddenly, light was free to move. This light, now stretched into microwaves, is known as the cosmic microwave background, CMB, the oldest light we can see today. The Dark Ages and the birth of stars. For millions of years, the universe was a dark, misty place. But slowly, gravity started pulling matter together, forming the very first stars. These stars lit up the universe and began creating heavier elements like carbon and oxygen, building blocks of life. Stars gathered into clusters, forming galaxies, and over billions of years, the universe evolved into the magnificent cosmos we see today, filled with countless stars, planets, and galaxies. The present and future, a cosmic mystery. Today, the universe continues to expand, driven by a mysterious force called dark energy, which is accelerating the expansion. Scientists wonder what the ultimate fate of the universe will be. Will it expand forever, slow down, or collapse back in a big crunch? And so, from a tiny point to an ever-growing cosmos, the story of the Big Bang is the grand tale of how everything, including us, came to be. The universe is still writing its story, and we are lucky to be here to witness it.